Hello everyone, this is lesson 10. The goal is review logarithms and their relationship to exponential equation. Okay, let's do this one. Every addition equation has a corresponding subtraction equation that undoes the addition. That means if we have an equation, for example, right? So x plus 2 equal to 3. Then the unders will be subtraction because we have addition, right? So subtract 2 both sides to get x equal to 1, right? The next sentence said that every multiplication equation has a corresponding division equation that undoes the multiplication. So means, for example, if we have a 2x equal to 4, then division divided by 2 both sides, then we get x equal to 2, right? All right, the next sentence said that every power equation where the exponent is a number has corresponding radical equation that undoes the power. So for example, if we have x squared equal to 4, then we take the square root both sides to solve for x. So take the square root. But then when you take the square root, other side has plus minus because, let me write down first, because we have a 2 square equal to 4, and then negative 2 square equal to also 4. That's why we need the other side plus minus 4. Okay? All right. We can have another root, which is x cubed equal to 64. Then we take cube root, right? So take the cube root. But other side, we don't need the plus minus. When it's even root, we need that. Then we get this is x equal to cube root, sorry, missing cube root, right? Cube root. And then there will be 4 to the third power, which is 4, right? Okay, the last one, we have every exponential equation where the exponent is variable has corresponding logarithmic equation that undoes the exponent, right? So we have a b to the x power equal to y, and we have log base b of y equal to x, right? So let me give it to you number first so that we understand. So example, so we have the exponent, so 2 to the third power equal to 8, right? This is the same as, this means the same as, in math, we are reading this one if and only if. Okay, then we have log base. This is a base, right? We learned before. This is a base. So this is a base, and the power will be other side. Then answer will be here. Do you understand what I'm saying? So I want to make a 2 as a base, and then power other side from the log, the format gives the 8 as answer. So in that case, this is other side, right? And this is answer. And this is a base. You guys are okay with this? All right. So how do you read this one? This one we read b raised to the power, same b raised to the power of x is y. Okay, how do you read? The logarithms with base b of y is equal to x, or we can just read log base b of y is x. We'll read it this way, okay? All right. Now, we have a base 10 here. So we don't see any base. That means base 10. Log means log base 10, right? Base. Okay, so let's answer this one. Log 1 is equal to 0 because we don't see the base. That means base 10. So 10 to the other side will be power, right? Think 10 to the other side. Give us the answer, right? So other side will be 0 power. Answer is 1, right? So this is answer. This is the other side. Okay, so we have log 10. That means the answer, the blank is 1 because 10 to the other side 1 equal to 10. That's the answer, right? Okay, now log 0.01. And then what's the blank? It's -1 because 10 to the -1, which is 1 over 10. Oh, that's the point, right? So it should be, hold on 1 second. Should be, yeah, so I made a mistake, right? So 1 over 10 is 0.1, but they have a 0.01, so it should be -2, right? It should be -2. So -2, then 2, right? So that will be 1 over 100, which is 0.01, right? Okay. This is impossible, the last one, because we cannot think 10 to the some power makes -10. Which one is that, right? Impossible, right? All right. Okay, let's move on. So we have base E. So base E means log base E, right? Okay, same as ln. So they have ln, which is we called natural log, and then log base E, right? With natural log. All right, so let's answer this one. ln 1 means we filled up the blank, the blank. So e to the some number, so think e to the other side make an answer, right? Other side. Answer. So this is answer. This is the other side. Other side. Okay. E to the 0 power, which is 1, right? So there will be 0. Okay, how about this one, right? So ln E means same as log base E, right? So log base E of E, right? Okay, so this means what is the other side? We have a base, other side to make E, right? Yeah, supposed to be 1, right? So the answer is 1, right? You guys understand what I'm saying? So basically, I mean this one is equal to 1, not E equal to 1, right? I have to make this one more clear. Is it okay to you? So this is the pink. E to the 1 to make E, right? All right. Then in that case, what do you get? We get 3 here because base E to the 3 equal to E to the 3, yeah? It's okay? All right. Now, how about this? The base E to the other side to make 1 over E, that is -1, right? Because E to the -1 to make 1 over E. Yeah, you guys okay with this? Everything is in that case the base E. Looking at the other side, this is the other side, and this is the answer. Yeah, okay. Once again, this is impossible because we cannot think base E to the what power to make -1, right? So we cannot find, so this is impossible. Okay, now we have property. So natural of x, natural log of x equal to y, same as e to the y power equal to x. So think about this. This is base E, right? So other side gives the answer, right? So base E to the other side, which is y equal to x, yeah? All right, now, we need to solve logarithms. So isolate term of a logarithmic, one side of equation, and write equation in exponential form and solve for the variable, right? Okay, let's do this one. 8. We have 166.5 equal to 96.12 plus 17.43 natural log of x. Okay, so we have a natural log of x here. So we need to get rid of one by one, everything, right? And then solve for x later on. Okay, now we need to get rid of the term first, which is 96.12. Okay, then we have 70 equal to 17.43. Now it's a multiplication, so divide by 17.43 both sides. Then we have 70 over 17.43 equal to natural log of x. Okay, now will be, if we have natural log of x equal to y, this is y, right? Then we can use e to the this equal to x. All right, so I am using this property. So following that, think this is y, right? So we have e to the y equal to x. There will be e, y in the case 70 over 17.43 equal to x, yeah? Okay, so x will be, if we calculate this one, so there will be 55.8678. Is it okay? All right. Second term, second one. So we have log and 3x minus 9 equal to 2. Okay, so if we don't see the base in the log, that means base 10, right? Okay, then we knew there will be 10 to the other side equal to the answer, right? Okay, then x is the right side, so we add 9 both sides. So we have 100 or 9 equal to 3x, right? And we do divide by 3 both sides. Then x will be equal to 109 over 3, which is 36.33. Okay? All right. Now, so they say that the amount of a shell natural gas in China in billions of cubic feet can be modeled by the equations of T equal to that, right? T is the number of years after 2010. How much the natural gas was there in 2015? So 2015 and then 2010. So 2015 to So 2000, 2015 minus 2010, which is 5, right? So number one, g of 5, which is 0.0117, 1.75 to the 5 power. So if we calculate, this is a 0.19209. I'm sorry, 03. It's a billions of cubic feet. Okay, number two. How is the amount of the shale natural gas in China changing over time? Is it increasing? So what do you think about this one? It's increasing over time, right? So it's increasing over time because so we have g over t equal to 0.0117, 1.75 to the t. And then we knew this form is what kind of variable we are using last time? C, C and a to the t, yeah? So a equal to 1.75, which is greater than 1. So exponentially growth, right? The growth. Okay, number three, what year will the volume of a shell natural gas be 2.5 billion cubic feet, right? So we need to find the T. So we have 2.5 as a volume, and then 0.0117, 1.75 to the T. Okay. They don't say anything, huh? They don't say anything. Okay. Now we want to find the T, so for T. Then we need to get rid of this one, right? So multiplication using division on dust, right? So division 0.0117 both sides, 0, right? Okay, then we have left side 213.675 equal to 1.75 to the t power. Okay, now, I don't know why they put this one here. Okay, I want to use this property. So this property says that if we have natural log u to the r power, then we can bring down the power, right? So bring down the exponent, right? So I want to use that properties. So in order to bring down the power, we have to take the natural log both sides. So take the natural log both sides. So we have a 213.675 equal to 1.75 to the t power, right? Okay, now we can bring the t. So t and natural log 1.75. And then t is here. It's a multiplication. We can divide by with this number, both sides. So there will be natural log 1.75, both sides. Okay, that will be t equal to, if we calculate this one, will be 9.5. So it's a 9.5. Okay, but then they ask us what year, right? And then t is the number of years after 2010. So 2010, right? So we added them plus 2010. So it will be 2019.58. So we can say that the 2020 year, right? Okay, let's move on. So let's do this one. We are using the property number 2 to solve. Okay, so number A, we have 5,000 equal to 1,500 e to the 0.053 t. Okay, so t is there as an exponent, right? So we need to divide 1,500 both sides. Then we have 3.3333 and then e to the 0.053 t. Okay, t is the exponent. We want to bring down the t. In order to bring down t, we take the natural log both sides. So let us do that here. So it's a 3.3333 equal to e to the 0.053 t. And then once again, we can bring down the t with the exponent. So it will be ln 3.3333 equal to 0.053 t natural log of e, right? Okay, so we knew natural log of e, which is 1, right? So if we divide by 0.053 both sides, then we can find the t, right? So t equal to this one. Which is 24.07. Okay, let's do second one. Second one has e to the 5x plus 7 equal to 0.51, right? Okay, once again, x is in the exponent, right? So we want to bring down, so take the natural log both sides. So let's do one step because we had experience earlier. And we knew the natural log of e, which is 1, right? Okay, then we have a 5x plus 7 there. Then we subtract 7 both sides. Okay, be careful. We don't want to subtract. So I want to write down this one in front because I don't want subtract 0.51 and 7, right? So we have a 5x equal to negative 7 natural log 0.51 and then divide by 5 both sides. So we have x equal to negative 1.5347 if we calculate. Okay, let me show you how to calculate this one, right? Negative 7. So let's using decimals. Scientific decimals. Okay, so negative 7 plus natural log of, so let's do using function here. So ln, right? And then 0.51. So go to main, 0.51. Missing one. Huh. Oh, we did not divide by 5. So I want to divide by 5, whole thing. Then negative 1.5347, right? Round up. So this is how we use the natural log in decimals. All right, I don't have to screenshot, right? Okay. Oops. Almost done. So last question, I think. Yeah. So here, the number in millions of women in the workforce can be modeled by W over T equal to 37.6 natural log of T minus 81.2 and more information there, right? So the first one, what does the model predict the number of women in the workforce will be in 2030, right? Okay, so once again, 2030 minus 1950, that would be 80. So we are using t equal to 80. So W of 80 equal to 37.6 natural log of 80 minus 81.2. Please don't subtract, right? So this is natural log 80. Yeah. Okay. Now, let's get rid of a term first. 81.2. Oh, sorry about that. We're not solving, right? We need to calculate when t equal to 80. Heavy. All right. So if we calculate everything using decimals, then we can get this one as 83.56. It's millions. Okay. Second part. In what year the number of women reached 80 millions, right? So we have 80 other side, and then 37.6 natural log of t minus 81.2. Now we need to solve for t, right? Okay, t is here. So we need to get rid of the term, which is 81.2. So we have left side 161.2 And then t is there, we divide by 37/6 both sides. Then we have other side is 4.287. Natural log over t, right? Okay, now how do you solve for t? We cannot divide by ln, yeah? That's not so simple, okay? So previously we take the natural log, right? But in that case, we take the base e, both sides, okay? So we take the base e instead of take the ln, right? So it will be, if we take the base e, both sides, let me write down, take base e, both sides. Then there will be e to the 4.287 equal to e to the natural log of t. Okay, then let me explain to you this one. Okay, so we know that log base of e of t is the same as log ln natural log of t, right? Same, right? Yeah. Okay, that means we knew if we have logarithmic, then what's the base? We knew base to the other side equal to answer, right? Okay, this is other side. This is the answer, right? If we are using logarithms format, right? So there will be base e, other side will be natural log of t. And then what's the answer? It's a t. Yeah. It's okay? All right. Then this will be t. So we have e to the 4.287 equal to t. This is the answer. Okay, then if we calculate e to the 4.287, then t equal to 72.75. Since the time, so we make a 73. Then once again, t start 1950. So we add them, 1950. So we get 2023 year, right? Okay, let me show you how do you find the E, how to calculate this one, all right? So E to the 4.287. So let's do it. E, where's E? I don't see the E here. Then go to the function. There is, right? E to the power, and then 4.2, go to main, 4.287, missing 8, 7, which is a 72.74789, which is a 72.75, which is a 73, which is the same as we got earlier, right? Okay, so looks like we done. Thank you for watching. Bye. No battery. No battery, my laptop.